Pragnadeepa Learning Center.
Today, we will try to understand an important and useful algebraic identity, that is a plus b the whole square, or even you can change the variable and say x plus y the whole square. So basically what we are trying to do, try to understand that we are adding two terms and squaring it. So as we are aware of, a plus b whole squared is a squared plus 2ab plus b squared. So let's try to understand what is the geometrical meaning of this algebraic identity. See, we know that if you square a number, geometrically, it can be the area of a square. Say, for example, if I take, say, 5 squared, which is 25. So geometrically, one can understand that the area of a square of side 5 units is 25 square units. So in that sense, square of a number means we can treat it as an area of a square. So in the same sense, students, let's try to understand the left-hand side. Keeping this example in the mind, we can think that if I consider a square with length a plus b units, the area of the square will be a plus b the whole square. So suppose I take a square with the length a plus b. So the length of this square is a plus b. And obviously we know that all the four sides are equal. So even this length is a plus b, even this length is a plus b, and even this length is a plus b. So what is the area of this square? If I ask this question, what is the area of the square with the side a plus b? Yes, it is nothing but a plus b the whole square. The area of the square is a plus b the whole square. Now the challenging task is to understand the right hand side. Students, understanding the right hand side, you have a square and you have b square term and you have a term called 2ab. So how to visualize this geometrically? To visualize this geometrically, what you can do is you can divide into three different geometrical figures. See, as we are aware of, with this example again, square represents something area of a square, and here b square can also be represented as an area of a square. So plus 2ab can be geometrically represented as an area of a rectangle with length or breadth a and b respectively. So I need two rectangles and two squares to represent this identity. So how to construct that? That is the question. So let's try to understand by taking the same square that we have chosen, that is a plus b the whole square. So what we will do is we will consider a plus b the whole square in different way. So what I'll do is I construct a square with this length a units and this length b units. Now students, observe that if this length is a unit, the complete length and even this line is parallel to that, therefore even this length is also a units, and this will be also a, and this will be also b, because this total length is a plus b each side. So here also it will be b, here also it will be b, and here also it will be a. Now if you can notice that this one square of length a plus b units is divided into four figures. One is a square with length a units, the other one is a square with length b units, and another one is a rectangle with length and breadth a and b, and another one is also a rectangle with length and breadth a and b. Suppose if I ask you what is the area of this portion, yes, we tell that it is a square. The area of this portion is a square. What is the area of this portion? Yes, the area of this portion is b square. Then what is the area of this? The area of this is say B into A or A into B, because we know that the multiplication is commutative in this sense. And what is the area of this? Yes, the area of this is AB or BA, whatever this. So if you can notice that I have two rectangles of same area, that means irrespective of the order of the multiplication, the total area I can write it as A square plus b square plus ab, which is raised to a square plus 2ab plus b square. And hence, geometrically, I can tell that a plus b whole square is nothing but a square plus 2ab plus b